morning.
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 Good morning, everyone. Sorry, I'm late.
Morning. I guess we can go get started. I was hoping Paul would be here, but I think but he gave me some feedback offline, so we can discuss it. Let's start back up here. Okay, so he gave me a lot of feedback on the ECC thing. So I think I had some stuff wrong in there, and then he talked about some possible options on how to reinterpret some of this ECC data. So I guess just to level set what happened last time. So previously we were trying to use some tables from Wikipedia, basic ECC codes. I don't know if they have a specific name other than anyway. We decided not to, after some discussion, Paul recommended we just take the parity tables from the the link layer spec, sorry. And then so I tried copying those in and massaging the text a little bit, but honestly, I didn't have a chance to understand the algorithm. I think I understand a little bit better though now, but there's still some more work to do. But he pointed out a variety of, well, there's just some typos and stuff first, but the bigger issue was that the table itself was didn't quite mesh with their packet format. So first off, there was the wrong number of bits, which I fixed, easiest fix. But there's the bigger problem is that the table, and again, I've got a truncated version of it here because it keeps going. Obviously, with the link layer specs, it's bigger packet size. The table has the basically the ECC bits on the starting at 0. So 0 through 7 are the ECC bits, where our ECC bits are the high order bits. And he pointed out that, well, we could potentially, rearrange the labeling in this, like basically add another row here and then say where the message packets map to this code word parity table, or we can organize the parity table. And so I tried it both ways so we can discuss it. So sorry, let me go back up here. So this is the original one. This is from the basically well, it might be easier to read it from the in a spreadsheet form. Anyway, this is the original one from the link layer spec. And you'll see again, it's broken up into chunks of 64-bit, or sorry, 32 bits here just for readability. But you can see again the identity matrix here, which represents which is really just going over the ECC. The ECC bits are on the lower order bits. And then a modified version of those, swapping them around. I pulled the ECC bits basically out and then made them the higher order bits here. The problem with all of this, again, it changes the ordering of the bits down here. And I think I copied everything wrong, right? But he wasn't sure whether the syndrome translate correctly when you do this. So I still, I guess, have some work to do to see if that even if it all still works. I mean, in theory, I think it does the same thing. I'm not sure why it wouldn't, but it does need probably a little more due diligence, and I can probably code that into a spreadsheet in order to do some checking.
Yeah, I have a quick question. I mean, do we know what was the motivation for the file spec or the link spec to choose a non-standard ECC algorithm?
Why the link layer spec used a different algorithm?
Yes.
No, I don't know. I mean, they use a standard algorithm from a white paper, but they didn't use the same one that's on Wikipedia. The one on Wikipedia is pretty simple, I think. I think this one's so this one has some, so I don't know why they picked it specifically, but this one has some advantages in that I don't think that the one on Wikipedia tells you exactly where the error is with a simple lookup table. You have to do like a two-stage process. Where this, I think you calculate your syndrome, and based on the value of the syndrome, you know exactly where the error is in a single error correction. You don't have to do a two-stage parity process, I don't think. That would be my guess. But again, I'm not super familiar with either algorithm. This is just me kind of reading between the lines.
Okay, thanks.
So just to be clear, the number on the bottom is the syndrome. If you have, if your syndrome comes out to be 0, I think, again, let me back to the text. I think you have no error. Yes, it's 0, you have no error. If it's odd, you have an error, and you just do a lookup on the bottom row here and find out exactly where your single error is. And if it's even, then you have a double error that's uncorrectable. And so I think it has a very simple decision tree. I think with the original one, if you look at the one on Wikipedia specifically, is only it's either single error correcting or double error detecting, depending on how you do it. And if you want to do both, you have to do a full parity as well. So I think you have to check the full parity first, and then you have to check the then you know, to determine whether there is an error there. I don't remember the full decision tree there. It was a little unclear because it's not the one on Wikipedia is not a secded table by itself, right? It's just one. This has, I think, both of them built into a single syndrome. Or maybe not single, maybe that's the wrong word, wrong terminology here, but it's built into one stage.
I can't read from my phone screen, but does this one consider the code bits being located at the power of 2 indexes? In other words, when it calculates the parity matrix,
Oh,
it assumes the code bits are not at the end and kind of sprinkled inside at the location of 0 to 4 and so on and so forth.
yeah. So this one is different. This one it assumes the bits are at the
At the end.
Yeah, at an end. So it assumes in the link layer spec that they're 0 through 7. And we're like 92 through 100, right? So I made 2 different versions of it and put them in the spec right now. Like one's through 0 through 7, which matches the link layer spec. And one of them is 93 through 100, right? Which matches our message format. And so number one, we need to make a decision whether we want to reorder them like that or whether we just want to reorder the labeling in the table, because we can do either one. Like we can either reorder the bits like I have it right now, or we can keep them in the low order bits and just put labels there saying, oh, these actually cover message bits, whatever. And then the other question is if we put them to the high order bits, does that break any of the math? And again, I haven't done the algorithm, so I'd have to go actually do that and make sure if we want to do that.
One more question. This is from link layer main band. This is the ECC that is using
Link layer, yes, the transaction link layer main band spec.
Generally, I think there is advantage to be compatible between not pulling ECC from here and there. But since Rom has an implementation, I'd like to get his feedback on it.
Well, my implementation is completely different, anyways. So I think we have diverged quite a bit from there, anyways. So I would probably say, since we are trying to match the link layer spec and be consistent with it, I think my opinion would be to move it to the lower order bits, exactly how the link layer also specifies.
So then the question then becomes, so okay, if we have it in low order bits here, right? The question is do I change the labeling or do I change the message format? Because the message format seems like it would break other things.
Not necessarily, right? I mean, the message, if you change the message format, I think all the bits would get shifted, but the feeds will still remain intact, right?
I mean, by message format, I mean, right now we have ECC as 93 to 100, right?
Right. So that will
If you
just move
if you wanted to match the message format of the link layer spec, those would be 0 through 7.
correct, and everything will get shifted down by 8 bits
Correct.
from there, right? So but then the I mean, I would assume that whoever is going to develop this are going to have structs. So I think that the impact to others would probably be less. Maybe since Paul has an alternate implementation as well, maybe we can ask him for his opinion. But I'm pretty sure that Paul will probably agree that we should keep this consistent with the main band ECC methodology.
So I think Paul's feedback is just to renumber the columns. To basically do what I did in the second one here, where we basically just move the ACC and the high order bits to the here. That was basically his feedback. I don't think
I
he's.
see.
I mean, maybe he didn't consider just changing the message format to better match link layer. Again, I can ask him. Yeah, these are all based on Paul's suggestions.
Okay, got it. Yeah, maybe we can just leave a note for him here and then see. I mean, he's fairly quick to respond, so maybe we can just leave that note and see, take his opinion as well.
Okay, yeah, I'll do that. So I guess as an action for me, I'll check with Paul on whether we should just change the message format and then, based on my time availability in the spreadsheet, I'll go ahead and I kind of want to understand this anyway better. So I'll see if I can quickly code up some sort of proof for if we swapped them around, is the syndrome calculation still maintained? I don't know why it wouldn't, but double check. And see what happens. Does that make sense?
Yes.
Okay. All right, let's move on. We covered a good number of things last time. I think I left some in here, I think just to I left some in here just to make sure that we can cover with you and Paul as well. So we'll hit those as we go down. So one slightly new thing is I did add a timing diagram. I think it's pretty simple, but if you guys think we need to add some stuff to make it more illustrative, just let me know. I did it in a spreadsheet rather than trying to use a Visio or anything. So, mileage. Just so it's portable along with the Google Doc that we have here. But if you guys think we really need to make it more illustrative or something like that, I can whip it up quick in Visio to make it a little more pretty. But I figured I think it was the point was a pretty simple the point was had to have just a pretty simple illustration rather than some sort of complex use case. But again, not a lot of stuff that we're showing off. So I guess let me know if you guys see anything in this that we need to do, or we need to add another diagram to show any special cases or anything like that. Okay. Let's move on. So we talked about last time, I added all of the fields to each of the all of the field assumptions to each of the packet types in the packet descriptions here. Command descriptions, I guess they're command descriptions, but they're really packet types. I guess one leftover question from that is we don't actually define what the assumption is of the bits outside the length field. My guess would be don't care, but I just want to make sure that we don't need to zero them out for some other reason that I don't even know. So I left that as a to do. I'm sure Paul might have a opinion on that. Yeah. Okay, that was the only thing left here. So yeah, again, if there's anything with the field assumptions that I put there that you guys disagree with, again, let me know. There were a number of changes down here. I reshuffled some of the bits. I added length, I guess, since our last discussion long, because we were missing length in the configuration register. I think we changed the name. We changed the description of local and prior and a partner error to better match it. And then we added this whole general flow down here in order to better describe what the intended use of the register is. Did we lose you, Helia? You still there?
I'm still here. I switched
Okay.
my phone to larger screen.
Okay, just double checking. Okay, yeah. So we added this whole general flow thing down here, which is it's a list. That's basically a quick flow diagram, a quick list of steps for checking the registers.
This is very useful.
Yeah, I don't think anything's a surprise to us, but I think for the reader, it is definitely probably more informative, rather than just a register description. trying to remember if we had any revelations in this stuff. Yeah, no, we talk about pulling the go bit and things like that. So again, I think that was there was some other discussion about other possible bits you need to know there, but I think the general thought was that those would be implementation specific and don't need to be in our don't need to be in the specifications list of things to do, right? You'd have to do those outside the specification. I guess one action item we have left over, Rom, was if you can add if you want to add a comment or directly edit in a implementation note on hardware or software wait states. I think you wanted to say something in that regard. Just or if you want to put a general statement about what you think needs to be said, I can, if you want me to, I can wordsmith it or whatever. Either way.
Okay, I can add a comment and put it in the comment, and yeah, you could probably rephrase it to a better language that suits the spec.
Okay. Let's see what I think now we're getting into sections that we didn't quite cover last. All right. Oh yeah. All right. So we had more of a discussion about this local error code register, which is really how to say, a link bring up error register, I guess is really a more apt name, or at least the way that we have it described. It's like a link error register. Basically saying, where the link error occur and stuff like that. And there's some conflicting text here saying that it's read by the partner, but it sounds like it's not really read by the partner. I think there's a question about whether we need to change the description here, change the register format, or remove the register. And I think we need to, Ram, you were gonna give this a little bit of a consideration on whether we need to do any changing here.
Yeah, I'm trying to refresh myself. What was I thinking here? This is for the local error, right?
Yeah, this is the local error register. And so we changed the description. So I guess, again, just to provide some guidance, the local error register now is, oh, wait, that's the bit. Well, okay, when you flag this bit, which I assume that register is associated with, it's a sideband error, the way we have it described right now.
Correct. So some error happened on the sideband protocol itself.
Yeah, so like parity or something like that.
Correct.
And we don't have, and all of the errors here are about the link layer itself, which I think we're trying to communicate with the PMR nowadays, right?
Correct. So the local error, I think, and the partner error, right? The both of them is now only required to track the sideband file level errors. That is meaning something went wrong on the sideband interface,
Right.
be it a bad packet structure or be it a bad ECC. I mean, those things. I thought we had a consensus that we want to handle those things early on, and that's what the local error and the partner error tracks.
Right. So if we want a local link error register, I think, I mean, I guess maybe there's some value there. Again, I guess there's two different things. I mean, the PMR is for you to communicate with your partner, right? So your partner would write a link error to you. But I guess if you're trying to communicate up to the software side of your implementation from the control, well, I guess that's a question. Would the controller even know there is a link
I think yes, it would know because most so you just give an example of partner writing a PMR back, right? So the partner would write a PMR back itself implies that something went wrong in one of the calibration on the partner side. And if something goes wrong in the calibration, obviously, I mean, you have to interrupt the local processor anyways. And part of that, sending that PMR over to the other side is going to be handled in that interrupt service routine.
Right. And that would probably be implementation specific anyway. So you
That will be
don't,
implementation specific, yes.
yeah, so
So
we don't need a dedicated register
correct,
for communicating that. And
correct.
so, okay. So then the question becomes, do we need to have well, okay. We have a local error bit anyway, right? So, I mean, we can have the registers fine. The question is, do we need to change this definition then? Do we just make it all proprietary here, I guess? Because
No,
this
so
will
for
be link
these,
state
so
stuff.
are these
No, link state.
also the
Same
error
thing.
code register? Okay, oh, so this error code register is for the local and partner error code, right? So yeah, I think bits 14 down to 12, whatever is there, I think those can probably be removed. Or is it the PMR? I'm confused now. I'm a little confused. Wait a second. Oh, this looks like a PMR error table, no?
This is well, the name of the table is local error code register.
Oh,
And
I see.
we have that listed as a register in the local wait, right here. Local error code.
Right, because most of the error, I agree with you. So what you're basically saying is, I think most of these error codes can probably become, I think we can remove it,
Yeah.
because they are going to be a part of the PMR communication as well. And we can only limit the local error and the partner error to specify protocol level errors on the sideband interface and not protocol level errors that would happen in any of the calibration states.
So I guess so just for the sake of completeness, again, we have a local error code bit and we have a partner error code bit, right? Depending on where the sideband error happened, right?
Right,
Um,
right.
but we don't have a partner error code register. Do we want to just make this because both of those registers are local. Do we want to just combine those into one register here and just say error codes and have a and have a field for local and partner?
Yeah, I think that would be I think sufficient because yeah we have 64 bits, right? I mean, and we only need like 2 or 3 bits of encoding to say what went wrong.
Right.
So I think it would be a good idea to consolidate both into a single register.
Okay. Well, okay, since it is, think about this a second. Uh, so we call it local error code and we call it partner error code. Technically, they're both local. Um,
Yeah, and
anyway,
then the just one thing to remember is that partner error code fields they get returned to when we receive an error message on the sideband. So the sideband with
right.
a command type as error, that is what would go into the partner error code.
Yeah. All right. So let me put an action here. All right. So um, see, add a field. Wait, we already have. Okay, yeah, for then add a field. Corresponds to the bits in the config register. Change description. to local only. Change description to local only. Wait, for information about the error bit status, error bit codes, whatever. I'll think of something to say there. Does that all make sense? So again, let's just to be clear, this register is no longer associated with the link errors. It's only associated with sideband quote unquote phi errors, and that it goes basically along with the error bits that you have in the sideband configuration register, the local and partner error. And since all of the link errors should be handled with the PMR or implementation specific registers effectively. Does that make sense to everybody?
Yeah, agreed.
Okay. Hey, Paul, I just noticed you joined.
Hey, yeah, sorry I'm late, guys.
Hey, Paul, so actually, let's hop back up. So we were talking about ECC before you joined. And so I thank you very much for your detailed comment. So I tried changing the wording to match what you were saying and the typos and stuff that I did from the copy paste up there.
Yeah.
So I actually added two different matrices here. One that I didn't add the extra row, but one that basically matches your third piece of feedback and one that matches your fourth piece of feedback. And we were kind of discussing what would be a better solution here. One other possible solution that was brought up during the discussion was actually just changing our message format to better match the link layer ECC matrix. Does that make any sense? Basically moving the ECC bits to the low bits in our message format?
I mean, I understand why you'd want to do that, but that's simply because you want to match documentation. And I think that's a terrible reason for making hardware different.
Yeah,
You
well,
know,
I think the question was, whether we think it would save any confusion trying to be closer to the link layer. I think that was the comment at the time.
yeah, no, I mean, I like being able to start transmitting the message while we're computing the ECC bits, right? I mean, there is some latency improvement to be had by putting them at the end.
Okay. Okay.
I'm not sure
All
people
right.
take advantage of that, but but there is a definite advantage to having that at the end.
Okay. And then, and what is your opinion of the two possible methods here? I haven't done the math on the second one, and I kind of signed up saying, oh, you know what, I'll see if I can add some sort of check to the spreadsheet to make sure the syndromes still work from a couple of test cases or something like that.
Yeah, it seemed to for me they worked, but again, I'd like someone else's eyes to look at that.
Okay. I mean, I don't see why they would be different, but again, like I said,
Yeah, until you do it right.
Yeah, we actually do it. But okay, so your opinion is the fourth option here where we pull it out. And again, I because it's all chunks of 32, I just pulled out well, it's not really an identity matrix, but whatever you want to call this part of the front with the ECC and the high order bits. And then I basically kept it the same, kind of shifting everything. Does that all make sense? Is that where you're really kind of going towards?
Yeah, that's right. Yeah, because that way I think you don't need the extra row, right? I think, if you do it the other way, right, there is going to be some confusion about what that number represents. And so I was recommending that we have another, row. And in this case, you don't need that, right? Everything's like, that row is the bit number, the message number of the bit number of the message.
Okay. All right. So I think we have Paul's opinion here. Is everybody else clear on that? I mean, we have disagreement going with the what I'm showing on the screen right now? again, I think there's a little math left to do to double check this, but assuming that that still works, is that the direction we want to go?
Yeah, I'm okay with it. I mean, I like the idea that we can start transmitting while we are computing the ACC parallels. So that's
All right, so let me capture that real quick. Okay. All right. So I'll do that. I'll see if I can double check that offline. All right. Oh, and Paul, I added a really simple timing diagram. If you see anything we need to add to illustrate, I guess let me know. But I think, and I just used a Google Sheets to make the timing diagram, so it was portable with the dot. But if we need to get something fancier, I can whip out Visio and illustrate something else. But it doesn't seem like it was.
Oh no, I like the diagram a lot. The only recommendation I have is if you could add maybe a bit number row in there
Okay.
somewhere.
Like
I mean,
the clock number count, or like what do you mean by that?
yeah. Well, I mean, sure. The clock number count for the message, right? Like the first, I guess the first guy would be 0, right? For the first so T clock, that first period of T clock, that would be bit number 0,
Uh-huh.
and then the last one that has a dotted line in it would be what, 101? How many bits are there? Sorry.
How
how
many
many
bits
bits
are there on
in
what?
in a message?
Oh, you actually make, yeah, I didn't put a time break or anything like that in here.
Right. And so
Yeah,
that's okay. I don't mind that not being there. It's just it would be nice to show like when TF falls,
yeah,
right? Because it's not, it just you can't tell from TD where you are,
yeah, okay.
right, in the message. So again, just something that indicates what bit is being transmitted at that time.
Yeah, okay. Add a, okay. Yeah, I'll play around with that, see how clear I can make that.
Yeah, because that would be helpful for me and probably others as well.
Okay, so one other quick thing I wanted your feedback on, Paul. Data bit fields, data bits outside of the length, do we want to just make them don't care, or do we have is there any reason to require them to be zeroed?
I don't see any reason to make them be 0.
I don't
So
think anybody else has
I
that
would be
opinion.
happy. I would be happy with don't care.
FYI, we updated the configuration register because it was missing a number of fields from the packet, so length and things like that. Was there anything else? We changed some descriptions and stuff here. Another thing we added this little general flow area here too, talking about how the register is used. Uh, we do talk about the Go being used for polling, for as a busy bit or whatever. And then there, but We don't cover any of the stuff you mentioned last time with regards to your implementation specific thing. With regards,
Yeah, yeah,
actually
I think
don't
that's good.
remember all
Yeah,
the
I think,
details there. Yeah.
yeah, I think that's great.
All right, going back down to where we were. Okay, yeah, and the last thing we were talking about was changing the definition of this register, since all of this should be communicated in the PMR and not in a local register.
Yeah, I heard most of that, and I'm happy with all that.
All right, let's go down. Okay, this is the similar thing. There was. Okay. All right, so I added an ACK bit here. And again, it's called ACK yes based on the way Boppy described it. So I don't know if that's a whether we need to change that. But I got the bit in there. But there
Yeah,
was
I might suggest required.
yeah,
But
okay.
yes.
Yeah. Yeah, I'll go back. I was thinking ACK rec or something like that, but yeah, anyway. What was I thinking of? Oh, yes. So we do have a way of asking for an ACK, but there's no, I didn't see an ACK packet. And looking at this table, there, I don't see anything that says that would be like a code for ACK. And looking at this table, I don't see any codes for ACK as well. So I'm not sure what the behavior is we were looking for an ACK if an ACK is requested. So I assumed it would be you get a message in that requires an ACK. You process the command in your PMR. You process the command, and then you write a message back to their PMR saying which command it was and that this is an acknowledgement that this command was completed. Is that correct?
Yeah, sorry, I wasn't around when this thing was created, but that seems very reasonable to me.
No, actually, the original intent behind having this ACK is for adding kind of a firmware checkpoint. I mean, just to give an example of where this originated. So, say you're doing an RX calibration and you're in a certain step where you want the partner TX to send a certain pattern. So in that case, you will send a PMR to the partner saying, okay, I want your transmitter to send this pattern, send XYZ pattern. But that goes to the other side. The other side, firmware receives the sideband, it interprets it, it sets its transmitter to send that pattern or start sending that pattern, and then it would send an ACK back. So once the ACK that ACK is kind of used by the calibration software as a checkpoint to wait until the ACK is received in order to start the RX calibration on its side. I don't think we need to. I mean, in the meantime, if there is something else that is going on and somebody else wants to send something, if a different process wants to send a different message on the sideband, I don't think we need to block it. But again, I think all of this is again implementation specific. But the intent for the attack is basically to give software feedback that whatever you requested, the other side has completed that request.
Okay, so this is actually more complicated than I even thought it was. Okay, so the first question is, Ram, do you have an idea of what an ACK looks like already? Is it documented here and I'm just missing it?
I think the ACK was built into the PMR, one of the bits of the PMR to say the previous request was completed. So if you look at the PMR bit pattern, I believe Mapi had some encoding in the PMR itself to So it's
So
act
this
yes.
is the bit that I added. So this is actually, well, here, let me change that real quick. Whoops. So that's the bit I added.
Okay, I think we also defined one PMR type to say previous command is done. I need to probably look at this in my laptop.
This is the things here. So let me
Yeah,
just
prior
scan it again.
instruction response. I believe that is the prior
Prior
instruction
instruction.
response. I think
Okay.
that's
So
what it is.
111 and 0 or F's. Is it down here as well? Partner previous rec done? Is that what we're talking about? Yeah,
Yeah,
okay.
previous red done. Yeah, partner previous red done. And so that was my implementation where I had partner previous red done. I think Bapi expanded that to have a lot. I mean, cover a lot more cases.
So if
To
you're
make it
potentially
generic.
interleaving other commands with this, how do you know which one acts? I guess you can
So
only
I
have one act out at a time and that you have to serve that on your side.
correct. So you can. I mean, say for example, you're independently trying to bring up several slices. So each slice would be connected to a corresponding TX slice, right? So I thought when that along with that partner previous read done, I thought Bapi added some additional fields along with it to say what slice is sending back that command if we are in a situation where we are bringing each slice independently.
Okay,
So
he has a not done command as well.
yeah, I think that not done command is for some error. If somebody requested something that is not supported, I think that's what is that not done. So yeah, I mean, I didn't have that not done in my implementation, and for me it was very simple because in my implementation, all the slices were bought up at the same time, so I didn't have an option. I didn't have a problem of knowing what slice is going to be bought up and what slice is responding and act. So I didn't have that complexity. But I think when we put this to discussion, there was a general requirement that from an implementation perspective, there may be cases where it is beneficial to have control or finer granularity control of whether we are bringing up a single file slice or whether we are bringing up a multiple file slice or whether we are bringing up and all the files along an edge at the same time. So that finer granularity was required, and that's the reason why we added all of these things into the table. So yeah, I mean, if you want to make the spec as simple as it can get, then maybe we can just say that software should, if a software has sent us command that says ACK required, then at the software level, it has to wait until an ACK is received before sending the next command. So that would probably make it very simple. But it would also mean that we may not be able to bring up multiple slices independent of each other. We'll have to, I mean, if we either choose to bring up one at a time or we choose to bring up all the time.
Trying to think about how I would deal with this. Sorry, this is again it's more complicated than I was expecting. Okay, let's talk about the two different possible returns that we have here individually first. So like you said, we can treat it as if an act is required, then no other commands should be sent until a response is received. The partner previous rec done specifically. Or I guess either one. I guess you can treat them together. So either one, either that or not done. The problem with not done is means that you need to check the state and, I mean, if this was a hardware accelerator or something like that, I'd say, it's invalid state or something like that, right? You have to rebuild your stack. But that's not true here necessarily. You may have just failed well, I don't know, training or something, right? So you can, I guess, in theory, try again. Or maybe go into a repair state or something like that. But so it's not necessarily invalid, but it's something you need to address. So, okay. So I think I agree with your statement there, Rom. I mean, I don't want to throttle people in terms of being able to stack commands or something like that, but it sounds like I'm trying to think of all the implications you would have and what we would need to think of from a spec point of view if you do allow people to have multiple outstanding, because both of those commands don't have any there's no information there other than either an acknowledgement or an error code, and there's nothing in reference to either what they are or what the problem is, right? So you'd have to communicate that separately with an error code. Speaking of which, like what, I'm trying to think about what. Okay. All right. All right. Yeah. Yeah. Okay. So I was going to say, why wouldn't you just respond to an ACK with an error code if it's an error? But you
Yeah,
may,
agreed. Yeah, I think you're right. I think that not done probably was not required. I think we could probably just because if it is not done, it would mean that there is some error that happened, and we can simply respond with an error code instead of saying not done. So I think
well,
yeah,
I'm trying to think of is there any situation in which you would try to execute a command. Oh, so the other thing I could think of that you would do here is that if that not done may be a busy issue, right? You need to like a retry. Like, you submitted a command and it is taken and the system is busy doing something else and it's not going to be executing that command in a timely manner. It might send a not done, or something like that. Is that useful? Or would that also be an error that we would rather stack in here?
yeah, I think that would probably go out as a timeout error anyways. I think we have a timeout error code as well in our PMR error this thing. So um I'm also trying to recall why that not done was added. Because it was added. I think I was not in the meeting when it was added, so I need to try to think of why Bapi would have added that. But but then you're exactly correct in saying that if there was an error in the partner that avoided the partner from executing that command, it is probably better for the partner to send it as a PMR error message that we already have it well defined instead of having a yet another not done bit. Um, why was this not done error? Paul, do you recall if that not done was for sending some, if there is some requirement for sending back-to-back command, was it added to block the sender from sending the next command? Do you recall?
I'm sorry, Ram. I think this predates me. I came in pretty late, so yeah, I wasn't around when that decision was made, and I can't imagine. I'm with you 100% right now, right? That this is just confusing, right? That we have we have a mechanism to report this not done thing via an error condition, right? And then to
Right.
get to Brian's comment, right? I don't think we should like send a message saying, "Hey, I'm really busy right now. I'm not going to do your thing right now. I'm going to get around to it later." I think that's the mechanism of the ACK thing, right? If the ACK is delayed, that's fine. It's like we're doing something else and we haven't gotten around to it. But you shouldn't assume that we're done until you get the ACK.
Correct. So I think I'm okay removing this, or just marking this as something that is marked for removal or something like that. Because I mean, it is going to make it very complicated to support this not done mechanism.
Well, all right. I'm gonna comment this and then we'll let it stew in everybody's head for a week before we find. And maybe I'll give it a cross out or a partial cross out or something.
Yeah, maybe partial. Yeah, maybe just cross it out this week, and then yeah, I think both me and Paul can probably think over it, and if we have the same feeling next week, maybe we can just remove it.
Okay. So I'll need to add some, let's see, let's see, let's say add. And that, okay. So again, just to keep it simple, that I'll add to the flow that no other if an ACK is requested, that no more commands can be sent until a rec done is received. Yeah, I'll just leave it like that. I think if people want to do multiple outstanding or have more complication here, right? I think from a spec point of view, it's just undefined behavior, and you can deal with that as an extension or something like that. Not that we have an extension mechanism, but again, something that is outside the scope of the spec.
So before we run away, I just want to give a shout out to Brian, right? You're doing an awesome job with this.
Thank you.
I'm really impressed with what you've done and how you're making this thing better, and I appreciate that so much. I'm just apologizing because I haven't been able to help more, but I think you're doing a great job.
Thank you very much. I think I was talking to Ron last time. I think we're pretty close to putting the final polishes on this and getting it out for review. So I think we're probably a couple of weeks away from just making a final pass at this. And
yeah, it seems like it to me too.
Yeah, and I completely second Paul's thoughts here. Thank you very much, Brian, for getting this done.
Yep,
thanks.
thank you. Bringing everything together. Awesome.
Thanks. Well, on that note, it sounds like we're out of time here. So I appreciate everybody for coming on the call.
Great. Thanks everyone.
Yeah. Bye-bye.
Thanks. Bye.